Hi guys, today's lesson we're going to be learning 1.1b, in which we're going to learn to convert decimals to fractions, and so that's our goal. Our goal is to learn to convert terminating or repeating decimals into fraction form. Now before we can actually go ahead and learn to convert those terminating or repeating decimals into fraction form, we need to take a look at some different types of decimals that exist. And there are actually three different types of decimals that exist. The first, which we see in our goal, is called a terminating decimal. And the definition of a terminating decimal is any decimal that ends at a specific place value. So terminating decimal is decimals that end at a specific place value. Examples of those would be 0.26, 17.8, or negative 3.1514. All of those end at a certain place value, and so those are all terminating decimals. The next type of decimal that we have is called a repeating decimal. In a repeating decimal, those are decimals that continue forever, but they have a repeating pattern, and that's the key with the repeating decimals, that they have a repeating pattern. So for example, we have 0.1111111, we have 2.535353, and then we also have negative 17.181181. Okay? Now, oftentimes when we see those specific types of repeating decimals written that way, that's one way of writing them. We can also write them another way as well. So if we have 0.111111, where the 1 repeats forever and ever, we can rewrite that simply as 0.1 with a repeating bar over the 1. All right? And I believe we've seen that all before. Our next example, where we have 2.535353, where the 53 goes on forever, we can rewrite that as 2.53, again with the repeating bar over the 53. All right, and finally with our last example, where we have negative 17.181181, where we see that the 181 is repeating, we would rewrite that as negative 17.181 with a repeating bar over the 181. Okay? So that is our second type of decimal, repeating decimals. Those can be indicated either with 3 dots at the end of the number, which indicates that the decimal goes on forever, or a repeating bar over the decimal, which again indicates that that particular number repeats forever. Now so far we've talked about 2 of the 3 different types of decimals, terminating decimals and repeating decimals. Those 2 types of decimals, terminating decimals and repeating decimals, those can both be written as fractions. So anytime that we have a terminating decimal or a repeating decimal, those numbers can be written as fractions, and therefore they are known as rational numbers. And so it's important that you guys write this down. It's important that you know that a rational number is any number that can be written as a fraction. Okay? Not all decimals are rational numbers, but all fractions have to be rational numbers. Okay? So make sure you write down, all rational numbers can be written as fractions. Make sure you get that written down. So we've talked about our first 2 types of decimals, terminating decimals and repeating decimals. Those 2 types of decimals together are called rational numbers. There is a third type of decimal, and those are non-repeating decimals. And those are decimals that continue forever without a repeating pattern. Okay, they might still have a pattern, but those patterns don't repeat. That's the important distinction between repeating decimals and non-repeating decimals. Non-repeating decimals might have a pattern, but the pattern doesn't repeat itself. So let me show you some examples of those. An example of that might be 0.27491. We said that there's no pattern in those numbers at all, but those numbers go on forever. Okay? Another non-repeating decimal would be negative 1.21222324. So we see that there's a pattern there. We're going up 21, 22, 23, 24. There is a pattern there, but it's not a repeating pattern. Therefore, that is not a repeating decimal. It's still a non-repeating decimal. Even though it has a pattern, the pattern does not repeat. So it is a non-repeating decimal. Now these non-repeating decimals, those are going to be known as irrational numbers. And an irrational number is any number that continues forever without a repeating pattern. And the important distinction between rational numbers and irrational numbers is that with irrational numbers, we cannot write those numbers as a fraction. That's the big distinction between rational numbers and irrational numbers. Again, irrational numbers cannot be written as a fraction. So up above the definition for irrational numbers, where I have those two examples, obviously those are two examples of irrational numbers. Some other examples of irrational numbers might include the number pi. We know that pi is approximately equal to 3.14, but pi does not equal 3.14. It's close to 3.14, but pi is a decimal that goes on forever with no pattern. Okay, so pi is going to be an irrational number. Another irrational number will be most, but not all, square roots, and we'll talk more about square roots at a different time this year, actually coming up within a few lessons. But most square roots, not all, but a lot of square roots are going to be irrational numbers. All right, so now that we've gone ahead and we've taken a look at our three different types of decimals, now we want to take a look more closely, more specifically at terminating decimals and repeating decimals, and we want to learn how to actually take those different decimals and rewrite them as fractions. And it's really pretty simple. So for our first type of decimal, again, we're looking back at terminating decimals, and any time that you're dealing with converting a decimal to a fraction, we need to look at place value. I would encourage you guys to write that down. When converting a decimal to a fraction, we need to pay attention to place value. So in this first example that we have 0.28. 0.28. We know that, or we should know that with decimals, and you don't have to underline what I'm going to underline, I just want to show this to you. Our first number to the right of the decimal, that's called the tenths place. The second number after the decimal is called the hundredths place. Okay? And those keep on going on forever. Tenths, hundredths, thousandths, 10,000ths, hundredths, thousandths. They get difficult to say, but those are the different place values that we have for decimals. So if we're going to go ahead and convert a decimal to a fraction, we have to pay attention to where the decimal ends. So in this particular problem, in this particular example, the decimal ends in the hundredths place. Therefore, what we're going to do is we're going to take our decimal, which in this case is 0.28, so the number to the right of the decimal is going to be 28. And because that ends in the hundredths place, we're going to place that over 100. So then our fraction becomes 28 over 100. Now, we are not done here. One thing that we need to always make sure of, and this is another thing that I want you guys to write down, we need to make sure our fraction is in simplest form. Write that down. We need to make sure our fraction is in simplest form. So if we have 28 over 100, we want to think of what the greatest common factor of 28 and 100 would be. Now, if you don't know what the greatest common factor is, that's fine. You can go ahead and start simplifying. Just make sure that your problem is completely simplified at the end. So when I think of the numbers 28 and 100, I know that the GCF for both these numbers is going to be 4. So I'm going to divide the numerator by 4 and the denominator by 4. And when I do that, 28 divided by 4 gives me 7. 100 divided by 4 gives me 25. Alright, 7 over 25 cannot be reduced, it cannot be simplified any further, so that is our final answer. So we see here that 0.28 is equivalent to 7 over 25. They're not written the same way, but they are still equal to each other. Okay, so that's our first example. Now, if there happened to be a whole number in front of the decimal, let's just say that, and you don't have to write this down, this is just so you guys can see it, but if there was a 5 out in front here, if it was 5.28, then our answer here would be 5 and 7/25. Okay? So just make sure that if there's a whole number in front of the decimal, that we place that whole number in front of the fraction as well. All right, I'm going to undo that. Now, for our second example, this one is not a terminating decimal. This is a repeating decimal. It's got that repeating bar over it. We approach it in much the same way, though. 0.5 repeating, it starts repeating at the tenths place. So we would go ahead and we would take our numerator is 5. We get that from our decimal over 10. Now, however, when we see this repeating bar, that tells us to subtract 1 from our denominator. Okay, the repeating bar tells us to subtract 1. So instead of getting a fraction of 5 over 10, instead our fraction is going to be 5 over 9. Okay, so 0.5 repeating, that is going to be equal to 5 over 9. Now again, if there was a whole number out in front, let's say we have negative 3 out front, then our fraction would be negative 3 and 5/9. Okay, so just make sure that that whole number in front of the decimal becomes our whole number in front of our fraction. All right, so two types of decimals that we can convert to fractions are terminating decimals and repeating decimals. Non-repeating decimals, which are also known as irrational numbers, cannot be converted to a fraction. So it's only those first two types of decimals that we're going to be worrying about converting to fractions. If you guys have any questions, please write them down and make sure to ask when we come together for class the next time. Hope that you guys have a good rest of your day.